My name is Ed Wenck. I am the content director with CEDIA, and for the next hour or so, we're going to be speaking with a tremendous, talented individual, and that's not me. It is Mr. John Penney, and we will introduce John in just a second. But first, a gentleman who co-hosts the CEDIA podcast with me on a regular basis, Walt Zerbe, is with CEDIA. He is the Senior Director of Technology and Standards. And Mr. John Penney, who's been with more companies than I can even list. Please, first, a round of applause for our guest, if you don't mind.
Thank you.
John, give us the Cliff Notes version of what you've done, your experiences, and so on and so forth, before we break into this 5G and edge computing discussion.
The short version is I've spent about 25 years in technology, media, and entertainment, mostly with large media companies focusing on technological transformation and the delivery of content, and the business models that support that content delivery. And my background is in strategic finance, strategy, business development, business formation. And some of the names of the companies that I've worked with are Time Warner, HBO, Viacom, Starz, a research firm called Sanford Bernstein, and the like. So I've had the privilege of working with some very exciting teams and had a wonderful time doing it. And it's great to be here with the CEDIA folks this morning. And so excited to see you in the Netherlands, since I just flew in from Los Angeles.
Everybody doing the elbow shake and so on and so forth.
The coronavirus, oh boy.
And I have to hand it to John. John went through quite the experience flying here with the storms and everything else. It took you how many attempts?
Yeah, 24 hours to get here from Los Angeles is a long trip.
That's bananas. Yeah. It's like flying to Australia or something. Well, he's here and we're happy because we have you on the podcast on a fairly regular basis. And the last one we did regarding 5G and edge computing was about a year ago. You had just attended the 2019 Mobile World Congress at that point. So it's going to be interesting to find out where we've come in that past year since we had our first discussion on this subject together. First, some clarity, a reset. 5G, what is it? Where are we with its rollout right now?
Okay, that's great. So just from the audience perspective, how many of you work within sort of the realm of communications that deals with 5G and those sorts of things? Anybody in that world? How about in the world of just general media, in-home media environments? Okay, we got somebody back there. B2B, you're in B2B technologies and like, okay, great, because great thing about 5G is it's a general purpose technology. We're gonna cover all those areas. So just to get a sense of where the audience was from. So the way I think about 5G is if we look at the progression of the prior generations of mobile standards, 1G, 2G, 3G, 4G, 5G, they're actually sets of specifications that then allow hardware and software manufacturers to make actual technologies that deliver the capability for our phones, devices, and other things to access the wide area network. So 5G is an evolution, some might call it somewhat revolutionary, in the design of a specification that came out in 2017. It's called 5GNR, New Radio. And it was a design of a specification that's still being fleshed out and implemented to allow some very specific things to happen in wireless infrastructures. And those specific things are about managing the wireless infrastructure itself in a very unique and new way so that all frequencies, radio is light and it runs in frequencies. You might have heard that before. 5G is a very plastic and flexible model for managing your network, running at very low, middle, and high frequencies. It also is a set of specifications for chipsets, antennas, and the like, and the software behind them, especially when you get to very high frequencies, that allows for much more, allows for more devices and higher bandwidth to access the network with very, very low latencies, and we'll talk more about why that may be important. So to wrap it up, it's a set of specifications that's global. The ITU and others put the specification together, and then that leads to hardware, software, and ultimately the cool thing that I think we'll be talking about is where the service possibilities and the B2B possibilities of 5G globally go. So sort of a dry way of saying it's a bunch of lines of written paperwork that then lead to engineering output. But really, it's a very holistic view of a network and a new one that is coming quickly, and we'll give you more on that when we get to Ed's next few questions.
First of all, what isn't 5G? What is it not? What are the misconceptions about this thing?
There's a bunch of misconceptions. One is that it's something that is a natural progression in terms of your actual phone or antennas. And I'll talk very much between the consumer and the business to business or infrastructure aspect. So if you put on a really confused face if I'm confusing you, because then I might be able to save myself and hopefully make it more interesting for you. But what it's not is something in the US that you see as a marketing platform that is one carrier is using. It's called 5GE. That stands for 5G evolution. That's something that AT&T is using. And what they're really talking about is their 4G plant upgraded. The truth is every 4G plant is a on-ramp, to use a highway example, to the highway of 5G. So 4G will be coincident for many, many years, as 3G is still extant and 2G still exists, to 3 and 4G. 5G will work in the same environments that 4G and 3G work in, and they are very different. There's support of 4G going into 5G, which is why AT&T can make the claim that it's called evolution. Okay. But when you see things that are not a new handset that you need or a new Internet of Things device connected to something truly called 5G, then it's not 5G. The one other thing that it's not, and this is critical, and we'll talk about this because I hope to really give you a piece of information that somebody opened my eyes to. And what I'm trying to do with you all is pass along all my learnings that I've gotten from people who are willing to teach me and help me over the last few years. So you too can go out there and investigate this emerging area. But 5G is nothing about the backhaul. So the backhaul is if you have antennas all over your country or your city, you need to connect those antennas, and there's a spider-like web of fiber optic and radio connections, and those are existing today. 5G has nothing to do with that. And so when we talk about robotic surgery and others, I'll point out something that will, I think, open your eyes up to the difference between what's going on in 5G at the level of the tower, where it really is 5G, versus backhaul. So it's not evolution in terms of the marketing platform, and it's got nothing to do with the stuff running currently in the ground except for protocols and the like around it, Ed.
John, would you see that as a limitation, the backhaul?
It can be a limitation in two ways. One, you need backhaul to implement a large-scale wireless network, because if the different antennas aren't connected and then being routed through proprietary networks or the internet, they're not going to go to places that we need to get to. So if we don't have robust backhaul, then we have problems implementing new 5G networks, right, especially at high frequencies, where the antennas are very small and the propagation, we'll talk about the distance the signal travels, is very short. And the other piece of that is, okay, I'm going to say it now. I'm not going to leave you hanging, and I know you were thinking about robotic surgery. Have you heard about this low latency element of, if it's very low latency, which means a very low connection time on the network, you could have a surgeon in one place in 5G, they use this example at Mobile World Congress, and a patient 1,000 miles away getting a robotic surgery. Have you heard that? Anybody heard that example?
There you go.
Right. Okay. Do you want that surgery to take place over the open internet that is the backhaul?
Ooh. Yeah, I was going to ask that question.
That's the problem that we'll talk more about. That's a complete fantasy. It's a fun thought experiment that you could have a robotic surgery, and certainly you could set one up if you had some really powerful hardened systems to do it. But we'll get to the real of 5G and the future of 5G. But right now, it's not robotic surgery in the next year. So I just want you to know we're going to have some. We're going to lift up some rocks, and we'll see some worms and things rolling around that are the 5G myths that we'll talk about in a little bit.
So what are the pluses? What are the advantages of this communication over the others?
So anybody worked at a startup? Startups? Yeah.
Got a couple.
Okay, so when you have a startup, you're working with a blank sheet of paper, right? I mean,
Yeah.
you're starting with potentially a brand new market segment, you're building a new team, you're building a new product, software, and the like. That's really amazing because you're not carrying the baggage of the old. Well, 5G is somewhat like a startup to the extent that it was a total reconceptualization of the wide area network, the wireless network, as a future-focused carrier of almost anything that we could think about that today goes through wires. Let me clarify. We know that there are roughly 3+ billion people in the world, more, with cell phones today. That's a lot of people, right? And some have 2, and there are a lot of, hotspots and IoT devices connected to the 4G network. So we're at billions, right? So one of the things that the folks who were very smart in the engineering teams and the standard setting bodies around 5G said, what if we want hundreds of billions of devices connected? How will this network manage itself? How will these things even talk to each other? Some of you heard of IPv6? Okay, so that's the IP standard dealing with greater numbers of domains and individual devices on networks. Well, in an analogous fashion, 5G is a structured thinking around the amount of devices that could be on the network, almost inconceivably large, multiple hundreds of billions and more, designed for that. 2, very efficient use of spectrum. So light travels through the air. We can't see it until it lands on something. Radio waves are light. They travel through the air. They travel in relatively interesting paths that we think about as frequency bands. It's all humans have put the physics onto the natural world. And 5G makes very efficient use of those frequencies. Very efficient. So just the actual way 5G uses those frequencies, it's called the encoding paradigm that they're using. So you guys know it's called orthogonal frequency division multiplexing.
It's one of my favorite terms.
Yeah, OFDM.
Really rolls off the
cool,
tongue.
right?
Yeah, right.
Orthogonal, great word, means coming in from the side. That, along with the way that the engineers have designed the specification, gets you immediately 30% better use of the frequencies. That's 30% more capacity in the same lane that would have existed. And that's really great because there's only so much frequency bandwidth, i.e. spectrum out there. They're not making any more of it. It's physically limited, and a lot of it's used by government and other areas of the communications world. The last piece on 5G is it's a holistic network philosophy management structure. So it can manage very disparate types of frequencies, antennas, systems in a seamless whole. So if you think about older generations, 2G, 3G, 4G, most of them were at low frequencies because low frequencies go further and they tend to go through things better. Have you ever heard of the problem with satellite dishes that are small? And if it rains really hard, you can lose your signal for a bit. That's because you have wavelengths that are, with a lot of raindrops, shorter than the path to the satellite with all of the raindrops falling, or they get bounced off of raindrops. Well, 5G is able to manage very high frequency spectrum, mid-frequency and low frequency, unlike prior generations. And that's a unique new holistic way of thinking. So take billions and billions of devices, that's the first thing I said. Now managing your entire physical infrastructure, whether you're one wireless company or a country across low frequency, mid frequency, high frequency. We'll talk a little bit about that in the future, in a few minutes, what those different bands do, because there's complexity for delivering it. And then the last piece, because finally folks figured out we have security risk in almost anything that we're doing now on the internet. How many of you heard about, autonomous vehicles being a vector of hacking, or even home automation, light bulbs and cameras being hacked? 5G is designed to be more robust. That doesn't mean there's not places to hack, but at least it's designed with security in the network. So very, very hard to do certain things that can be done fairly easily today, like cloning SIMs, and very hard to do in 5G, much more hardened network. So think about the three things that I said. Greater speed. I also mentioned lower latency.
Right.
That's the connection time. 2, managing a broad infrastructure, low, medium, and high frequencies, heterogeneous types of hardware. And then security. And then what we've set the foundation for in those three areas and their subdomains is a new general purpose wireless technology set that's going to enable great new things that I hope we'll get to talk about.
John, I had a question. So I know we're going to get more into the application side of things, but you mentioned two words, home, and you mentioned the high frequencies don't penetrate things very well. So I think everybody out there is probably thinking 5G as device-to-device IoT things. Is it going to replace cable modems and other types of internet service to the home? Since the 5G may not penetrate the house, is it going to be kind of a to-the-curb service? And then you're going to still use it? Is it going to get rid of the traditional network in the home, the wireless access points and all that stuff? Can you address how you see 5G going there?
While it's speculative in terms of how each company would roll out a fixed broadband service, many people don't know that the United States has particularly poor broadband. In fact, the OECD is about 32 countries. We are second to last in price performance of broadband.
Right.
We pay the most for the worst service. And the interesting thing that the question is related to that Walt just gave me, there are about 50% of homes in the United States. We have about 135 million homes that only have one broadband provider, and that broadband has been brought down as a specification, lowered by the FCC to make it look like more homes have broadband. It's only 25 megabits. So 5G, to the question, absolutely can serve as a fixed broadband replacement for cable modem through the telephone system or fiber optics. But it depends on how much low frequency spectrum is available in the place where you're trying to roll it out. So Walt's question had a nice second piece. Well, high frequency spectrum in the United States, let's call it 3 to 4 gigahertz and up, is plentiful. There's a lot of it. It doesn't penetrate through walls well, even windows that have, coatings for heat retention or for preventing the sun from coming in. So if that's all you have, you don't have a great option for delivering wide area 5G. If you have, like a company, T-Mobile in the United States, more mid and low band, you absolutely can make a fixed 5G cable modem replacement, which would then be the first step to thinking about a holistic 5G ecosystem that went from outside your home into your home without the need for the traditional Wi-Fi router that we have today. And just to give you one more piece of that, 5G, remember I said it's holistic and designed for all sorts of network management, is perfectly capable of managing 802.11 environments, not the non-licensed 802.11 that you might have heard that we use at home, which is either B, G, N, A, C, and beyond, but a managed Wi-Fi in the home. So 5G could be this really interesting stepping point to either a home fixed broadband product from out of the home into the home,
Okay.
and then a home environment. So I give you a very long answer on purpose to show you the three phases of how 5G, if you have the right frequencies, could serve as fixed. Most companies don't have that much frequency to do it. Then the home is different, and we'll get to more. But that was a really good question, Walt, for framing it for the audience.
Some alarm bells have gone off in a couple of quarters regarding this.
Okay.
The Swiss have been concerned about health issues.
Okay.
Is this real? Is this propaganda from another government someplace? What do you know about that?
Okay, so I'm going to ask an audience participation question. How many people today in the audience, and this is not the answer to the question, so we're just taking a poll, worry about the radiation from their phone and their health?
Not that many.
I'll put my hand up because there's actually an interesting part of the question. I'm not a doctor and I'm not a biomedical engineering person. But, the higher the frequencies that are utilized at a specific power, the more damage they can have to human tissue, or any tissue that matter. So, how many of y'all have a microwave at your home? Right.
Now we get good participation.
Right. So micro, right? The word means very small, right? The wavelength of microwave is very small. It's at a high power, a tube makes it. And what does it do? It heats water. Do you want to put your hand in a microwave oven? No. If it didn't have protection, it would run without you could put your hand in it. You've heard about people who tried to, this is an urban legend, dry their dog by putting it in a microwave oven. Bad idea. You don't do that. Not only would it heat the body up, and that may have bad health impacts, but it also can potentially, at high enough frequencies, multi-gigahertz and up, 10 gigs, 20 gigs, at enough power, be a cancer-causing driver. Now, let's stop. That's the reality of high frequency at high power. The truth is that much of 5G will run on high frequency, but at very, very low power. If I told you your Wi-Fi router in your home is running at 5 gigahertz, some Wi-Fi routers are, and I bet you this audience has one in their home that is, you'd probably say, uh-oh. I mean, you wouldn't say, uh-oh, I'm running a router all over my home. Well, it's at a power that's low enough not to cause you any harm. So I am sure that there are certain situations with the right frequencies and the right antennas on the right device, putting that very close to your body, that people might be able to do experiments to show that there's danger. We need far more information about this at high frequency and at low power. But I will say to you, it would really only be a concern if likely there was a consistent place that you always kept your phone, not just talking. By the way, most people are using Bluetooth. That's also radio frequency. Doesn't seem to be too much of an issue there. Why? So let me net it out. I think there's a low probability it's going to have health impacts. Very low probability. Science will tell us, and I think it's right to be cautious going in because it's new at high frequency. But I really don't believe that the rest of wireless is causing. There are many more things that we're doing in our food supply and the like, and driving around and walking and riding bikes without helmets. If you live in the United States, you would never do that in the Netherlands, right? Oh, I know. Right. It's more dangerous doing that likely than it is carrying the phone, even at high frequencies.
I got another one to bring up,
Yeah.
not on health, but there has been reports that 5G is going to interrupt weather forecasting because it's the same frequency as Doppler radar, and it's going to take us back to the 80s for our accuracy in weather forecasting. Have you been following that, and have you heard that as well?
I've heard that.
And that's like from NOAA and some other legitimate sources.
So before I answer, let me just quickly explain the issue. So when you're using a radar, you're sending signals. You've been to the airport, right? You see the thing that swings around like that? That's the big radar antenna. It's sending signals out at very high frequencies that bounce off metal and come back, right? It's bathing entire environments in signals. So the problem with radar is it's not directional. I mean, it is a directional antenna, but it's swinging around like this. It'd be like taking, a giant pot of water and running a circle and all the water would spray out. Well, if you have that and you have 5G infrastructure, there's a high likelihood that there would be interaction between the two because at the right frequencies. And part of the problem is that until 5G is rolled out and you map where the actual radio frequencies are bouncing around, it's hard to make systems that can filter out what's 5G interference from what's weather radar. So I think we're going to roll out 5G in a way that will probably be along the lines of lower power in the low and mid bands, and then definitely low power in the high bands. And as we do that, we will see interference patterns, which have always happened in radio. And that will then allow us to understand, rather than turning a giant switch on and beaming 5G everywhere, we're going to slowly ramp it up as an evolution from 4G, and power at the high frequency will be low in the beginning. So for radar, you need the high power. And then to create the interference patterns. So I think we're going to see it before it happens.
So we'll adjust accordingly.
Yeah, hopefully.
As we roll it out.
I think so.
So interference, health, the potential obsolescence of certain devices. We've talked about some pushbacks here.
Yeah.
Are there any others that we're missing?
Yes. Cost.
Okay.
Okay, I'm going to give you a little secret. If you look at the report from the Mobile Industry Association, Global Mobile Industry Association, that puts on Mobile World Congress, the total revenue of the wireless industry around the world is about $1 trillion. It's a giant number. It's about as big as the automotive industry in a year. Their own estimate, GSMA, that's the group, their own estimate for the revenue growth for the next 5 years as of last year, so we'll look at their new book this year, was roughly only $200 billion increase, so $1 trillion to 1.2. Now think how many more people are coming online around the world with phones in all sorts of places and new IoT and connected technology. Well, the estimates for 5G implementation run north of $200 billion a year around the world, if you totally tried. So one thing that 5G is not is an immediate economic benefit to the companies that are rolling it out, nor to companies that use wireless like media companies or other, in-home home automation entities. It's not an immediate value driver to the network side. It's very important to keep in mind. We'll talk some more about that later.
Okay.
But on the consumer basis, I don't think we're missing anything in 5G.
All right.
We talked about the backhaul being slower. You don't want to have a surgeon halfway around the world, all that sort of stuff.
So now let's talk about practical applications.
Sure.
What is this thing going to do? How is this going to impact us in a positive manner? And more importantly, how can folks make money off of it?
Perfect. Let's talk a little bit about that. So I saw some hands go up. Who's in B2B again? You want to raise your hand? Okay.
There we go.
Anybody in B2B software and manufacturing? Okay. Got it. I think 5G, one of the immediate impacts that we'll see in 5G is in B2B environments, specifically in environments where there's industrial equipment and machinery, where things that have been wired, like industrial robots and the like, will now become wireless within the factory floor confines. And that will allow for a couple of really cool things to happen. One, so the B2B element, and if you go to a conference, this is a closed conference, but if you go to like Bosch Connected World, they make a lot of equipment for manufacturing. You'll start to see how this is going to play out. A lot of manufacturing now is about reconfiguration of lines and doing very flexible, fast manufacturing. And when you have a lot of cabling and a lot of systems running through traditional methods, even if they're closed VPN wireless, it's pretty hard to re-engineer things on the fly, and it's also very hard to give that equipment enough bandwidth and the low latency to have control, right? Because you don't want a robot. Like, the latency for 5G is talked about in the range of a millisecond, but let's just say it's 3 to 4, whatever the number is. You typically see latencies on the internet, if you were a gamer, of 2 to 3 microsecond latency. And on a normal 4G network, we could test it right now. I don't want to do it on my phone. You can use speed test. You might see, 14 millisecond to 20 millisecond latencies. Well, if you're making a factory that's running robots that are doing things on micron level precision, that's like, waiting an hour for the robot to understand what its next function needs to be. So the low latency helps in B2B environments, and what's going to happen is you'll have industrial environments that will now be 5G enabled. And think about that. Remember we talked about 5G being able to have billions of items on the network? Well, what are some of those items going to be? Sensors, low-cost sensors. Where are there lots of sensors now? Well, they're everywhere. They're in your phone, they're on your car, they're in your home, they're in medicine, health and wellness. So think about a manufacturing paradigm. Why do I keep coming back to manufacturing? Because I actually think this is going to be one of the key catalysts for 5G. We can talk about some consumer things, but this is pretty critical. Let's say you're making cars. What if, as you're making the car, your factory is controlled by 5G robotic systems and otherwise? Your car has 5G sensors that are used for the manufacturing process to understand how quality control and the movement of the car through the system is working. But then when the car leaves the factory, it goes from the 5G network in the factory to the 5G wide area network, so that it can be seen as inventory on the dealer's lot. How many miles has it been driven before you buy it? And now you have the car and it's yours. Now that 5G sensor network is helping you have predictive maintenance on the car. If it's 5 years from now and it's an autonomous vehicle, V2V, vehicle to vehicle, which needs very low latency, is there. And we've just described a seamless fabric of 5G opportunity that started in a very different place than consumers talking on their phone, which was Gen 1 through 4 of the mobile network. Now we've started from industry outwards, where there are trillions of dollars at stake, not just 1 trillion from the phone, like I described before.
So John, when we talk about data is the new oil, we're going to have a whole lot more data now. So there's definitely an arm on business side to managing, collecting, and doing something with that data.
Couldn't have asked for a better lead than that. So think of all the sensors, right? And think about the petabytes of data collected today. And think about it scaling dramatically. I mean, you get gigs and gigs an hour off of like a Tesla. There are a lot of Teslas in the Netherlands. It's sort of fun to see. And then you think about sensors everywhere, medical, bio, fabric of manufacturing. The data loads are going to scale. I mean, we think it's big now because it's video. I think you're going to actually see video data keep scaling for its use in B2B and other environments, and other forms of data scale just dramatically, which will be called localized data. It's not going to be called this. I call it, it's localized from the edge. Doesn't mean it's only useful locally. But think about this. All this data connected to, all these sensors, still jet lag, connected to 5G networks, right? Much of that data needing machine learning and types of narrow AI, artificial intelligence, applied to it to make quick decisions about which lane should the car be in, what is the appropriate temperature in the factory module to make the circuit board work, all of these different things. What do we need to bring to the party to make sure that decisions are made correctly around the data? We need edge computing and machine learning. Edge computing, the concept of doing computation at the edge of the network rather than in giant data centers at the core, which are now run by various companies. And that's a whole discussion we're going to get to, but a great point on we are going to have so much data, boy, it's going to be an interesting world.
And one of the places that you can collect that data and then use it in a really, really beneficial manner is in the home. For the CEDIA integrators that are with us today, when you think about the potential for wellness monitoring here, for checking on folks' health, et cetera,
Living in place,
and just general well-being, speak to some of those applications that are potentially out there for the home.
Sure,
5G,
that's a pleasure. So one thing you need to know about the United States is we have a very patchy healthcare system. It doesn't provide a lot of people with as much care as they need, and it provides people who have a lot of resources, money, with very good care. But it's patchy. So there's a lot of thinking, since all countries around the world are having trouble supporting their healthcare expenditures as technology of medicine, pharmaceuticals, devices goes up. There's a whole new level of thinking going on about how to create healthier environments in the home so that people can age more appropriately without having to live out of their home. So what that means is that as people live longer lifespans into their 70s, 80s, 90s, and beyond, Japan has the longest lifespan of any large industrialized country in the world. It's an aging population. But what we need to think about are really important ways in which the home and the people who bring technologies into the home and help consumers in the home will be able to create beneficial, technical and technology-driven hardware and software service environments that make your living at home that much more healthy, productive, and safe. Because if you're going to be at home, which is a good place to be, then you do need access to doctors. You might, in the US, we have to drive a lot, and there's distance to get to doctors. There's a lack of healthcare supply in areas like mental health and well-being. So you might see a home in which telemedicine and sensors around, for example, for older people. My wife is a professor of nursing. One of the biggest problems is falls in the home. Like if you fall and break your hip, that's a really big problem immediately. Well, think about a world in which your wireless network in your home, only because of the way the wireless signals are bouncing around in your home and can be captured by edge computing, knows that you've fallen because it can see that you're not moving around the home without any type of sound sensor or needing to wear a watch. Types of technologies like that will be readily available, but they won't be the types of things that most consumers will be ready to pop out of a box and put in place. So you're going to need expertise in the home, and we've only covered health and wellness. We could cover connected appliances, environmental control in the home, integration between automotive and home,
quality of air,
quality of life, audiovisual. We're going to have a whole new home environment where the ability to service that home environment is going to be critical in making sure the consumer is getting all the value out of the technologies that they're paying for on a monthly basis, the wireless service, new software services, and the hardware that will be in the home that will be lower cost, but I think has a really great opportunity to help people live more productively and for a longer period of time without stumbling on healthcare issues that are systemic to and are much not like Europe, because you have national healthcare in most countries, but maybe more like the US or even developing countries have issues.
And the sensorization here is a little less intrusive, at least psychologically, for the consumer, I think.
Very much so. Sensorization in the home for a health and wellness program could be a single type of, we'll call it, module. Could be elegant looking, sit on a table or be mounted on a ceiling. They could combine wide area networking, local area networking, and are you guys familiar with LiDAR, which is how autonomous vehicles it's a type of laser radar, think of it that way, sweeping around. Well, you can do imaging of a home in similar ways without having to use expensive LiDAR. And so devices that could be very non-intrusive could be talking about everything from your health context, and of course this all has to be done GDPR, all has to be done in a very secure way, but if you wanted it to, could monitor your blood pressure, your temperature, whether you're vertical, horizontal, sleeping enough, not sleeping enough. And I'm not saying be Big Brother, put this into your house and let someone snoop on you, but if you had an elderly relative, this might be really valuable. And if some health service were going to give you benefits for having these in your home, could be financial or could be otherwise, this is definitely a almost guaranteed, you heard it here, not first, but you heard it here, this will be an avenue of which 5G and those IoT edge computing paradigms will bring a lot of value to the developed and the developing world, because everybody has a mobile phone in the developing world.
And John, they're already doing gait analysis, and your gait is the way you walk, and they're doing that with the radio frequencies. And if your gait changes, then they can tell.
It's your own fingerprint.
Something's wrong.
Did you know that? Like the way you walk is an individual fingerprint. Yeah.
That's wild. Well, this is a perfect segue. Now we've kind of danced around the notion of edge computing, so let's talk about how 5G and edge computing intersect and inform one another and assist one another. How does this all work together?
Perfect. So we can do that. So the paradigm today of our world of the internet is we get data from servers that are in the middle of the network. Now, that doesn't mean they're actually in the middle of a country, but we think of it in an analogy to the central, remember central computing for the older folks in the room? It was a mainframe computer. Well, it was in the center of the network, and then there were terminals that radiated out. So let's use an example of we throw a pebble in water, and you know the circles. So let's use the center of where the pebble went in as the place where there is a data center that's run by a company like Microsoft, Google, Amazon, Facebook, large, Siemens, Philips, whomever it is. And that center is a 100,000 foot, million square foot cooled environment with lots of servers connected to the internet through giant backbones and requiring huge power and cooling. That's why they're being built up in the Nordic countries, a lot of them, because they get cooling and all sorts of good stuff, and they have great internet up there. So right now, when we ping data, like we call a web page, I'm going to use the simple analogy, and I'm going to make it a little more complex. Our request from our phone or our computer goes to the center of the network. The network says, Walt, or one of our esteemed audience members, is looking for this video or data, and it sends it from the center back out. Or if we need to do a computation, a complex one, on something like we're running a simulation, it goes from our computer to the center of the network and gets processed. Okay. The reality now is concentric circles are pebble. There are other circles where we've said it's too inefficient for signals to go all the way, or requests to go all the way to the center of the network. Let's place things closer to the customer that are data centers that have some processing in them, but not as high powered as those ones back in the middle, the giant ones that Google, Facebook, Amazon, Apple, Samsung all run, but they're closer to the edge. So these might be thought of as intermediate data centers. And they're run by companies like Akamai, Microsoft has them, Amazon, Netflix has them for delivery of video. So the dominant paradigm of something that we call cloud computing, which is what I've just described to you basically, which is the centralized notion with data at the edge, cloud, it's in the cloud, it's not in a computer in your home or at your factory or whatever, is now morphing to a environment that includes a lot more power to process at the edge and do very, very important calculations at the edge. What might some of these be? So far, so good? You guys got it? Okay. So you have a phone. It's as powerful as a supercomputer 10 years ago. It has unbelievable sensors. It can take amazing pictures, accelerometer, temperature, barometric pressure, light, all these different things. It also has very specialized chips. It's in the last 3 or 4 years that do AI type of processing, graphics processing, all of the things that are elements of what are called, in the traditional sense, machine learning, pieces of specialized AI. It's happening on your phone today. Well, your phone is the ultimate in your pocket edge computer, right? So imagine the power of your edge computer phone now placed in a pervasive fabric around us in data centers and small boxes all over, where not only radio and devices are talking, but computation of data, of sensor feedback, images, temperature, control systems, all happening right there. What does that do? That allows much more dynamic activities and decision making to take place close to where the action is, which is at the edge, where cars are, where we live, where we work, than having it to travel microseconds to the middle and come back, which is a highly limiting issue. Or just to go to the traditional edge Akamai data type center, even that's slow. So 5G and edge computing work hand in hand to 5G, seamless connectivity, billions of items, low latency, edge computing, taking the outputs of those to do useful things, and all of a sudden we have a revolution in general purpose technologies. What those are like are electricity, general purpose technology, plugging into the wall, water in pipes was a general purpose technology, general computation, general internet. Those are the ones that transform societies in the world. So edge and 5G, sorry I had to go long on that, but that is the next nexus of the types of things your companies, you're all going to be in this. You guys are going to define what this means and the power of it by what your companies do. Notice I haven't said there's 12 examples that are going to make people $1 billion off the bat, because people are still figuring it out. I don't mean individuals making companies billions of dollars. You guys are here to invent that future. That's what this show is about. ISE, integrated systems, right? So I think that's the edge in 5G.
John, is it fair to say that besides a speed advantage, it's going to give us a efficiency advantage in bandwidth management and in energy usage?
100%. So let's just take the bandwidth piece. In general, I told you there's a roughly 30% increase in just the pure, what's called spectral efficiency of 5G. If you had two lines here like this, and it's a slice of spectrum, right? I would be able to cram, and we're pretty good at cramming stuff into spectrum these days. It's all math. It's just math, like compression. We can put 30% more in this with the 5G, OFDM, orthogonal frequency division, multiplexing, and the other technical schemes. So that's really great. But what we can also do is utilize multiple swaths of bandwidth in very efficient ways that we haven't been able to in the past. Sort of like, imagine in the old days, we can only drive on a freeway that has sort of walls between the lanes, and we're allowed to change lanes every 5 or so miles, right? That would be really inefficient, right? You couldn't get in and out, and speeds would be limited by the slowest vehicle in your lane until you could move. 5G allows, remember, here's my lane of bandwidth. It allows me to expand that and contract that dynamically when you need a lot more bandwidth. It's like a highway that had walls between lanes. I've taken the walls away, and now things can move freely in a different way. The thing that it adds when you have edge computing is if you have very high quality sources of power that are not too carbon heavy. So if you had edge computing near solar power or wind, Netherlands got a lot of wind, or tidal or nuclear if you're in France or others, very, very high quality opportunity to reduce the overall carbon footprint of wireless and the systems that connect to them. A very strong increase in potential green sustainability. But we have to get, and I would encourage you all, people to think more about that, because the network architecture and the edge computing allow for that. But I haven't heard a lot of people talking about it, so we could make that our little, I'm big into sustainability. That could be a real thing that we could all push for here.
Excellent. Well, that's a great segue into my next question, which is how do people get more information about this? Suppose they want to get out ahead of the curve here and find out exactly what's coming next,
yeah,
or how they can actually implement some of this technology into what they're doing. Any resources that you can think of?
Yeah, so if you're new to it and you really want a fairly good quick take, I can't recommend more highly the annual data book that the GSMA puts out on the global wireless business. It's a free resource. So if you're beginning to understand 5G and what it does, it gives you a tremendously strong primer on 5G. You can also go to the ITU and many websites that will talk in very practical terms around what 5G is and what it isn't. You notice I haven't talked a lot about consumer applications initially. There are not that many consumer applications that 4G LTE can't handle. So only a very few specific, like virtual reality with very high bandwidth, or telemedicine where you would need very high resolution, or
maybe drone delivery in the
AR,
yeah,
AR, VR.
Yeah, mostly the VR piece.
Yeah, right.
But they're not places where there's billions of dollars of market today, like we switched to video very quickly on 4G. So I encourage you to be very, very broad in your thinking about 5G by going to industry sites. There's some very strong, you can look them up, mobile magazines on, Fierce Wireless, good example. And there are 50 of them. I'm not just pointing them out. I will say on the industry side, for B2B, look for industrial gatherings like this that are going on now all around the world in terms of 5G and B2B, because that's where you're going to find. I love that a lot of you are in B2B here. That's where there's a huge amount of action. And then I'd say a last resource, not a last, but if you can find any quality research reports from the investment banks, and a lot of times they'll have summaries online. It's a very good place to look, because investment banking research analysts are out there talking to hundreds of companies, and they're very good at synthesizing the immediate state of the art. And since they have to comment on the viability of strategies of companies to try and predict whether their stocks are going to do well or not, they'll give you, not necessarily with full predictive power, but they'll give you the upsides and the downsides. And so that's a little known resource that you can find. You're not going to find the whole reports, but you're going to find either journalists talking about them, which is fine, or the business summaries.
Terrific. Do we have any questions? Does anybody have any
Please.
questions for John?
Even if it's...
Yeah, go ahead, sir.
Sorry, just to see if I've understood that right. What you're saying about edge computing is it's going to move from being the echo type server to some sort of vision that's happening almost like a Have I understood that correctly? That's what you mean by the next generation of the
Yes. So
Did you catch that? Could you
Can you
restate
repeat
that?
the question?
I'm going to repeat it because it was hard to hear. So if I don't get it right, you're going to tell me, and then I'll get it right. Okay?
Outstanding.
So the question was, what type of computational paradigms might be happening at the edge with real edge computing versus just moving from the center to the edge. Is that good enough summary of it? Okay.
Perfect.
So here's the answer. It's very, very hard to do a lot of very high-speed processing on things that would be around massive data inputs like machine learning data sets, image recognition, massive motion related context like autonomous vehicles in the center. So if we take the concept, edge computing is taking the same concepts of central computing or even what's on your mobile phone and placing far much more of that edge CPU, so central processing unit, edge GPU, graphical processing, specialized AI chips at the edge, and letting your devices talk to those. That edge is in the cloud, very close to you. And so therefore, with data inputs coming really quickly, that edge node can help decode what's going on and make decisions based on the algorithms behind the software to help inform a situation that is at the edge. 2 cars driving down the highway, which should take the lane first. An ambulance that needs to be routed quickly through traffic. A visualization of a design that some graphics, some architects or designers are doing in a room that needs to then be pushed out to their colleagues around the room for a shared collaborative design experience. So it's really about in the cloud bringing all of the amazing things that we now have on phones, but at much higher power and in the center of the network to right by you to create what has generally been called pervasive computing, the ability to have all the power you need wherever you need it. And when I say all the power you need, reducing the power you need for your device to have access to this cloud-like fabric of computation and not just connection.
Yeah, there'll be a whole new industry to maximize tasks on the edge.
Yes.
And algorithms.
Yep.
Terrific. All right. One question in the back. Go ahead.
So as a company that installs and designs like residential, small, commercial networks, I really see this as a huge thing in the future as this transition of, you're not putting in a router anymore. So kind of what's your estimate, right now as we're going to put this great, wonderful network in your house and then, 5G comes out and wow, now you can do all this. What's really the projection of when kind of that transition would happen?
Yeah, when are we going to go from the traditional Wi-Fi into the 5G
Thank
home
you
network?
for reminding me
Yeah.
to try and put some sort of timelines. So the historical analogies may be slightly different because things speed up, right? Because what we've done with 4G makes things there's already a lot of IoT devices on 4G. There's video running on 4G. So we have some basic, fabric out there that we're working with. So if you look at 4G and you think about roughly 4G is 2010, mass deployments. It was roughly 2 to 3 years that, really large scale deployment of things like social network or the starting elements of video, which ends up now being we watch, Netflix, Amazon, YouTube, and on our phones. Took roughly 3 years for the beginning phases of what would become dominant paradigms to start to take hold. So my sense is that as 5G is being deployed for reasons in the United States that include just being able to market something called a 5G phone, hence this thing called non-5G, which 5G evolution is marketing. I think we have about 3 years to see the real ramp up of sort of structural opportunity sets to change the in-home environment and to change the industrial environment. So the invention of the things that will really happen in the home, of which we know many of the needs, low latency, high bandwidth IoT devices to move video around. Imagine a truly cableless home. Think about stadiums that have no cables to connect, 8K TV, 8K cameras. Believe me, I'm getting way too far ahead of myself, but that could be there. Volumetric capture in places where you want to see what's going on in 3 dimensions. That's all possible now, but it really starts to take off when you don't need wires to move it around. So we have things that we can place into this network, which makes me think the deployment scheme will be faster than 4G, definitely, which was a brand new, completely new paradigm. We built the fundamental pylons of industrial approach for both B2B and consumers, and I think we'll see a faster rollout to interesting B2B and critically B2B2C. I think that's probably what I want to leave you with, that will have new home environment, help transform the home environment so that installers and other people in the home and management of the home environment will be a real business sooner, not just some 10-year fantasy. I think that's the realistic time frame, 2 to 3 to 4 years.
I'd like to point out I think it's also going to be application specific. So you may still need to have 5G to the curb, but then within the home you might still need to have VPNs and firewalls and VLANs and traditional distribution, but you'd be doing 10 gig networks instead of 1 gig network. So I don't think it's going to completely always replace. No. It's going to be application specific, and you're still going to design and manage as you need to.
Yeah, terrific. CEDIA.net, the place to go to find out more on what Walt and I are up to. For what more on John Penney's up to, where can they go these days?
You can follow me on Twitter, which is John B. Penney, Penney. And then I'm also on LinkedIn if you want to send me a message there. It's John Penney, Penney. And I really am happy to connect with you and help in any way that I can.
All right. CEDIA.net, again, the place to go. And also for the podcast that this will become, and wherever you find podcasts, it's the CEDIA podcast. In addition to the streaming, we've also recorded this for a future show. John Penney, thank you all. Thank you very much.
Thank you so much for coming.
Appreciate it, folks.